Hello everyone. Let's solve this problem very quickly. We have y to the power of 3 plus y equals 30. Okay, the first thing to do is bring in 30 to the left. So we have y to the power of 3 plus y minus 30 equals 0. Now this is a cubic equation or a polynomial of degree 3, right? And because of that, we are going to have 3 solutions for this problem. Now let's get started. Now it's difficult for us to factorize this without splitting any of the terms. So I'm going to split this 30 so that we'll have y to the power of 3 plus y minus 30 will now be 27 plus 3, and this is equal to 0. Now y to the power of 3 plus y minus 27 minus 3 is equal to 0. But then I want us to rearrange this very quickly, so we get y to the power of 3 minus 27 plus y minus 3 is equal to 0. Okay, now the reason for this arrangement is for me to express 27 in index form. Okay, so we have y to the power of 3 minus 3 to the power of 3 plus y minus 3 equals 0. Now the next thing is for me to deal with the power here, the ones that have exponents here. Remember, if you have a to the power of 3 minus b to the power of 3, this is the same thing as a minus b into a squared plus ab plus b squared. Okay, so this is what we have, and then we are going to apply this right about now. In place of y to the power of 3 minus 3 to the power of 3, I'm going to have y minus 3 first, y minus 3 in the first bracket. Then in this, a squared becomes y squared plus ab becomes 3y, that is 3 times y. Then b squared becomes 3 squared, close the bracket. Then I have plus y minus 3, and everything is equal to 0. Now we continue. This is the same thing as y minus 3 into y squared plus 3y plus 9, then plus y minus 3. If you like, you can have this in bracket, and everything is equal to 0. Now we have the same thing here. We can factor out y minus 3 as a common factor. Then here I'm going to have y squared plus 3y plus 9, okay, then plus 1, because y minus 3 has come out and 1 will be left over, which will be equal to 0. Now let me open the bracket open what we have in the second bracket, y minus 3 in there. Then here we'll have y squared plus 3y plus 9 plus 1, and this is equal to 0. If we continue, then y minus 3 will be here, and here we have y squared plus 3y plus 10, and this is equal to 0. Now we apply the zero product rule. Remember, we want to get 3 solutions, so it is either y minus 3 is equal to 0 or y squared plus 3y plus 10 is equal to 0. This is a linear equation while this is quadratic. This will give us one solution and this will give us two solutions, even though there may not be a real solution. Now, let's go from here. Y will be equal to 0 plus 3, and that is 3. Now we have our first solution, and we can call this y1, which is now equal to 3. Now, to get the other solutions, we pick the quadratic equation over there. We have y squared plus 3y plus 10 equals 0. According to this, a is 1, the coefficient of y squared, b is 3, the coefficient of y, and c is 10. Now, what is the formula for quadratic equation? Okay, so we have y to be equal to, now this is the formula though, so a is 1, b is 3, c is 10. So in place of b, I'll have minus 3, positive or negative. Okay, so in place of b squared, I'm going to have 3 squared, then minus, we have 4 times 1 times 10. 4 times 1 times 10, right? So here I'm going to have 10 over here because c is 10. Now let us continue. The whole of this will be divided by 2 times 1, meaning that y is equal to minus 3, positive or negative. We have 9 minus 40. Everything is over 2. So that if we continue, y will be equal to minus 3 plus or minus 9 minus 40. That will give us negative 31, right? Okay, and the whole of this will be over 2. So that y from here becomes minus 3, positive or negative, square root of 31 multiplied by square root of negative 1. What I did there is to point out the negative over there, and then the whole of this will be divided by 2. And now if we continue with this, we have y to be equal to minus 3, positive or negative, square root of 31, and then square root of negative 1 will give us an imaginary number I, and this will now be over 2. Now we have our 2-in-1 solution. So let's get the three solutions together. y1 is equal to 3, y2 is equal to minus 3 plus square root of 31i, and this is over 2. Then y3 will be minus 3, okay, minus square root of 31i over 2. So these are the three solutions for the quadratic equation, for the equation rather. But remember that it is only equation 1 that is real. The others are not.